Hey, this is Mr. Herzon, honors biology teacher at Wooten High School, and today I'm going to show you how to make your cardboard amino acids. Yeah. Oh, you know, excuse the little piece of lunch there. So let's get right to it. Um, for this first slide, you're going to need um, what I created here is something a little bit special. Let me show you. Um, so in my cardboard cutout, on one side I put green post-it note and then wrote the C on it and then put tape around it and I snipped it um, to create where the bond is going to go. Okay. And I haven't done that for this one as yet. All right. So you're going to need some double bond oxygens, okay, and two hydroxides along with the two carbons. So let me show you how um, you're going to do this. Let me bring you into my little studio here. So I already have my cutouts already made. And actually, I can actually simulate how I did this. Okay, so here's my cardboard cutout. And here is my green post-it note. I just lay it right over, just like this. And now I'll cut on the perimeter of the post-it note. Okay, so there's that. And sorry, it's a little bit too dark. You can't even see. Maybe this will darken things up a little bit. Turn off that light. Close my shade, and actually, it's not doing anything. But trust me, um, it is green. Maybe if I hold it up, you see how it's green. And then you can cut this into fours. Okay, and there's two. All right. Now I can use a permanent marker to write the name of my atoms or combinations of them. Okay. So maybe I might need to hold on to these and use them for later. Okay, so let's go ahead and make my um, my carboxyl group. Okay, so I'm going to cut up here. All right, that's where my double bond oxygen is going to go. And then here's where my OH is going to go. So here is my double bonded oxygen, like this, because it kind of reminds me of a choo-choo train when I get the hydroxide attached to it. And there is my carboxyl group. Okay? All right, so the next thing that we have to do, I can move this over. Oh, that is so much better. Okay? Is make my the amino group. And it'll show you here for this project that you need two of the nitrogens and four of the hydrogens. Okay. I already have assembled my first amino acid right here. Okay. And the one that I'm building right now is actually going to be for alanine. I've already have done, I just showed you, I already had glycine. Now I'm making my model per instructions on the lab sheet. Here is my hydroxide group. Okay. So I got my carboxyl group and my hydroxide group. Okay. Well, let's bring them up here. Okay. So on the last slide, we're going to need, I made these using just um, printer paper on top of cardboard. You can see 3 carbons, and you're going to need up to 8 hydrogens. Okay. For this amino acid, like all amino acids, they all have 3 common constituents or parts to them. A essential carbon atom that I'm holding now, and I must have flipped the camera. Okay, there we go. So here's my central carbon atom. And there are 4 bonds to a carbon molecule. And the amino acid alanine has a methyl group attached to it, CH3. Okay, so I'm actually going to be making that first. And now my second hydrogen. And then following my third one. I don't know, I might be repeating the same thing. What I use to hold down these post-it notes and this paper is just a strip of Scotch tape. Okay, so now here is my methyl group, CH3, and this is going to be covalently bonded to the central carbon atom there. Okay, all right. Well, now I have 2 remaining hydrogens. I'm sorry, 1 remaining hydrogen to attach. Okay, so here is my central carbon atom. Oops. Oh, okay. Yes, yes. Okay. So, correction. Um, no, no correction. This is fine. This is my central carbon atom. And on one side, I'm going to have my nitrogen or the amine group attached to one side. Oop, I made a mistake. I actually cut on the wrong end of the nitrogen and then over here. Okay. So there's one of my hydrogens, and I did the same thing. Okay. Oops. I did the same thing to this hydrogen. We can't forget that. Okay. All right. Now I'm ready to assemble my amino acid. So I have, oh, that came off. Let's get this fixed. I'm going to attach the carboxyl group to the central carbon atom. There we go. And now on the other side, oh, I got this hydrogen playing around. Connect. And there I have alanine. Okay. Let me get my Okay, so now what I want to do, since I have both amino acids, all right, here is my alanine, and then right next to it, here is my glycine. So in order to bond these two together, we have to do dehydration synthesis. Okay, so I'm going to remove one hydrogen from the amino group of the lysine, okay, and then the OH from the carboxyl group of the alanine. And then combine these two together, and there I've got my water, okay, H2O. All right, let's bring it up here. And then now I'm going to create a special type of bond that's called a peptide bond between both of these amino acids. And let's see if I can do it. Hold your breath. There we go. Okay, so here would be my peptide bond. Okay, so here is my glycine. Here is, well, what's left over the glycine, and here is my alanine. So now this is actually called, since I have two amino acids bonded together, this is what you would call a dipeptide. Okay, and if I was going to attach a third one, I would now have a tripeptide. Most hormones that circulate in our body are only 2 to 3 amino acids in length. Okay, so we have a lot of dipeptides and tripeptides flowing through our bloodstream. And this is this rendition of the Carbohydrate Factory. Have a great day, everyone.